Okay, the circle review test. So first thing, just a couple vocab terms here. Name a radius. Remember, when you talk about a radius, it goes from the center of the circle out to any point on the circle. Whereas, oops, sorry, my hand's in the way. Whereas a chord is going to go from one side of the circle to the other side of the circle. So here, let's look at what we've got. We've got XB goes from the center to the side of the circle. So that one looks like it's going to be a radius. AB is a diameter, not a radius. BC is going to be a chord, and then AC is going through it, so that's actually going to be a secant, that new word we learned yesterday. Okay, number 2, name a chord. Well, we said the chord was a BC, so it goes from one side of the circle to the other side of the circle. And then number 3, name another radius. So we have AB, again, that's a diameter. XC, so that goes from the center to the side of the circle, so XC. Number 4, find the exact circumference of the circle. So first, let's do our two formulas. We have 2 pi r and pi d, and you'll be given those tomorrow. So we need to know either the radius or the diameter. So right now, we don't know this, but because it makes a right triangle, let's use Pythagorean Theorem to go ahead and find that other side of the triangle, or the hypotenuse. So we have 12 squared plus, these are congruent, so this is also 12, equals c squared. So if we solve for c squared, we get 288 equals c squared, and I'm going to go ahead and use some decimals for now. So square root of 288 is about 16.97. Okay, and remember, that's the diameter that we found, because we found the hypotenuse. So I'm going to use circumference equals pi times diameter. So circumference equals pi times diameter. So what we would put in would be the 16.97. Now here, this one's left in square roots, and I didn't reduce the square root, so let's just see which one matches the 16.97. So in my calculator, I would put in 12 square root 2. And there you go, right there, the first one matches 16.97. If I put in the next one, just to see, that one doesn't match. This one's just 12, and then this one is 8.48. So this first one matched this decimal point. So remember, exact circumference means you don't multiply out the pi, you just leave it in. Number 5, the circumference of a steering wheel of a car is 20 pi inches. What is the radius? So since we're finding radius, I'm going to use 2 pi r. Now usually we plug in what r is, but in this case we know the circumference. So we're going to put circumference in for c, and we're going to solve for r by dividing by 2 pi. So the pi's cancel. 20 divided by 2 is 10. Number 6, in circle F, CFD, so angle CFD is congruent to DFE. So these two are congruent. BFA is 100, so this is 100, and BE and AC are diameters. Now a couple ways you can solve this. I'm going to go about it. I'm going to go like this. So if I know AC is a diameter, that means this whole thing is 180. So if this whole thing's 180, and this is 100, then this piece here is 80. Okay, so then they say BE is a diameter. So again, you could do that's 180, or if this is 80, we know vertical angles that this is 80. And now since AC again is a diameter, then this whole thing is 180. So if this piece is 80, then these two pieces are 100, and I can divide it by 2 to find out that each piece is 50. So 50 for that one. And remember, you have to look at what they're asking. I didn't even look at this down here. Find the measure of arc DC. So remember, if it has that M in front of it, we're finding what the measure of the arc is, and so it's going to match. If it's a central angle, it matches the inside. Number 7, in circle K, HKG is 26 degrees. Find the measure of FJ. Okay, so a couple things. I would do again, just like I did above, how this is a diameter, and so this is HJ, so this whole thing's 180. So if I add 74 plus 26, and I get 100, subtract that from 180. So this whole thing was 180, and I added these and subtracted. I find out that the measure of FJ equals 80 degrees. Okay, number 8. So number 8, you have to make sure you read it very carefully. Okay, so it says points G and H lie on circle T. So let's draw a circle T. So that TH is 8. So that's a radius. And GTH, so there's G. The measure of GTH is 45. So this angle on the inside is 45. Find the length. So here, find the length of GH. So now we're moving away from the measure of the arc. We want to find the length of GH to the nearest hundredth. So in this case, we're going to use our proportion. Okay, so you're going to be given the formula right here, number 5. So let's go ahead and use that formula. Let me expand that. So on number 8 again, here's our formula that we're using. So arc length is what we're going to find. So I'm going to put x on top over circumference. Now they give you the radius is 8, so I'm going to use 2 pi r, so 2 pi times 8 equals the degree measure of the arc. So if the angle on the inside is 45, then the degree measure of our arc is 45 over the degree measure of our circle, which is of course 360. So cross multiply and solve for x. So I'm going to do 45 times 2 pi times 8 and divide that by 360. So 6.28. Number 9, if a pendulum 20 centimeters long swings to an angle of 30 degrees. So that means the pendulum is 20 centimeters. Find the length of the arc. So again, the length of the arc, so we're going to use that proportion from A to B. So we're finding arc length over circumference. Circumference is going to be 2 pi times 20 equals, so from A to B is going to be 60 because I have to add this whole thing. So 60 over 360. So if we put that in, we get 60 times 2 pi times 20 divided by 360. So 20.94 centimeters is the length from A to B. Okay, number 10. In circle O, AB is 12 centimeters. So from here to here is 12. Now, if I know this is 12, and this makes a right angle, well, sorry, let's keep going. OE is 4, and OF is 4. Okay, so these are congruent. Find CF and CO. Okay, so let's start with CF, because that one's the easiest one. If this here is 12 from A to B, and since these are right angles, then CD is also 12, which means half of that, CF, is going to be 6. So CF equals 6. Then if I want to find CO, you notice that's not even on here. So if I draw CO, that's a radius, but now I have this right angle. So I have this triangle here, O, C, and F, and we know this is 4. We just found out this is 6, and we want to find the hypotenuse. So Pythagorean Theorem. So I get square root of 50. So this becomes 52, and I want a square root. And so I find out C is 7.2. So CO is 7.2. I guess I should have put centimeters there. Okay, so you had to first know this one to then even find the CO. Number 11, in circle C, CL equals CM. Okay, so those are congruent. And ST is 28, find XL. Well, if ST is 28, because these are congruent and make right angles, then that means it's congruent to XY. So if XY is 28, I can divide that in 2 because this bisects it, and so we get 14. Number 12, if the radius is 7, in circle O, find XY. So the radius is 7, so from here to here is 7, which means since this little piece is 2, that means from O to this part here is 5. and I want to find x, y. Now, the only way that I would be able to find that, I'm going to draw a radius right here. So I have this right triangle, and I know this is 5, this is 7 because it's a radius, and I'm going to find this piece here. So if I find this piece, I can just multiply it by 2 to find this whole thing. So I'm still going to use Pythagorean Theorem. So I have a squared plus 5 squared equals 7 squared. And I get a squared equals 24. So I get 4a is 4 points, we'll round up to 4.9. So if I multiply that by 2, I get 9.8, we'll say. Okay, so that's a little tricky. I had still used Pythagorean Theorem in order to find this little piece here, but I knew what the hypotenuse was, and since they gave me this was 2, I knew what this long leg was. Number 13, find the values of y and z. So if a quadrilateral is inscribed in a circle, then opposite angles are supplementary. So 180 minus 110 is 70, so y equals 70. And 180 minus 75, these are supplementary, is going to be 105. So z equals 105. Number 14, find x. Okay, so you have two angles here. You've got a central angle. So what do we know about central angles? If this is 64, then this is 64. And then you've got an inscribed angle, and inscribed angles are 1/2 of their arc. So 1/2 of 64, so x would equal 32. Number 15, find the measure of ABC. So we have an inscribed angle. So first thing, we need to find this arc. So if I add 120 plus 100, that would be 220. Subtract from 360 would be 338. That's not right, sorry. There we go, 140. Missed a button. So this arc here is 140. Again, it's an inscribed angle, so it's half of this. So 1/2 of 140 is 70. Number 16, in circle O, the measure of CD is 130. So from here to here is 130. Find ACD. Okay, this is an example of an inscribed angle, so it's still 1/2 times its arc, which would be 65. Number 17, find the measure of angle 1. So this is the new formula that we talked about yesterday, where you have two chords intersect in a circle. So if I have the measure of angle 1, that's equal to 1/2 times the two arcs added together, which would be 115. Number 18, so similar to 17, but I don't know, I have this angle 3 here, but I don't know the corresponding arc. So instead, let's call this angle x and find that first. Okay, so if I find x, it's the same as above, 1/2 times 135 plus 105 is 120. And then, because this is a straight line, I know this whole thing's 180. So I do 180 minus 120, which is 60. Number 19, write an expression that could be used to solve for the measure of angle 1. So for the measure of angle 1 would be 1/2 times 3x minus 8 minus, plus 2x minus 7. Number 20, find x. So this, we have two secants. So we use our formula, 1/2 times 100 minus 20, which would be 40. And you're going to be given this formula. It's just a matter of setting it up correctly. Number 21, find x. So the whole circle is 360, and they gave me this is 100. So in order to find the missing part, we'll subtract that. And then let's do our formula. So I have two tangents, so 1/2 times 260 minus 100, which would be 80. 22, find x. So now I have two secants. So I have 130 and I have 40. Now because this is a diameter, I can find this little tiny piece right here by adding these two up and subtracting from 180. So this little tiny piece is 10. So that's how I can find the missing part for the formula. So in order to find x, I have 1/2 times 40 minus 10, which would be 15. 23, which equation could be used to solve for x? So let's go ahead and just set up what we would use. I have a secant and a tangent, so I have 4x. In order to solve for this, 4x equals 1/2 times this bigger arc, 12x, minus the smaller one. And then look for which one matches that. So 4x, not addition, it's going to be subtraction. So that first one right there. Okay, so it's just a matter of taking your formula and plugging in what you have. Don't let the number with the x confuse you. Just plug it into the formula. Number 24, in circle M, the measure of AB is 72. So that means from here to here is 72. Since I have a central angle here, that means that's also 72. And they want us to find BCD. Well, since I have this diameter here, I can just subtract from 180, and I get 108. 25, in circle A, AC is congruent to AF. So AC is 3, which means AF is 3, and AE is 5. Find EG. So we did one like this earlier. We have the hypotenuse and we have the long leg. Let's find this short leg, and then we can multiply it by 2 to find this long leg. Now I'm going to do Pythagorean Theorem, but I do know that's a 3, 4, 5 triangle. But if you don't know it, that's okay. So we have a squared plus 3 squared equals 5 squared. So a squared plus 9 equals 25. And a equals 4. So again, that's just this little piece here. So then make sure that you double it to get 8 to find that whole thing. 26, Arthur cuts a 30-degree slice of pizza from a 14-inch diameter. Okay, so this here is 30, and if the diameter is 14, then the radius is 7. Find the length of AB. So again, be careful there. Find the length of AB. That's that proportion. So I want to find the length over the circumference. So they gave us diameter, so we can just use that. Pi times 14 equals our degree measure of our arc over degree measure of our circle. So I can cross multiply that. 30 times 14 pi divided by 360. So we'll go 3.67 inches. And the last one, find the exact circumference of the circle. So let's use Pythagorean Theorem first to find the diameter. So a squared plus b squared equals c squared. 6 squared plus 8 squared equals c squared. And I got 100, which means c is 10. So exact circumference, if circumference equals pi times d, then I get 10 pi. And that's it. So remember, you will be given the formulas tomorrow on the test. Let's see, something like this. So you've got your central angle, remember you have to know that one. And then you've got your inscribed angles, your angle formed by two chords. This one is the most difficult one that people miss. Number 5, make sure that you look at that one and work on those on the review. Okay, otherwise, that is it. So good luck on your test tomorrow.